Today we're going to talk about object-oriented principles in Python. Okay, first, before we talk about the object-oriented principle, I would like to talk about the other paradigm that is also present in Python, and that, historically speaking, it was dominant before the object-oriented paradigm was introduced, which is the structured paradigm. So it's just that the paradigm, the programming paradigm, is just a way the data and the processing are organized within a program. Okay, now you should know that any program whatsoever, no matter how complicated it is, whether it's a machine learning program, a very sophisticated framework, no matter how complicated it might seem, it all boils down to exactly two things. There are some data, and then there's some processing that apply in this data. Okay, so we already established that. And then we started with how the basic building blocks of that there is. Then we have the basic data types and the basic operations, and then we keep adding on like layers on top of that, but the concept remains the same. We have some data, and we have some code or some processing that we want to apply on this data. Now, the concept, the idea of a paradigm, it just determines how the data and the processing that apply on them are organized. Okay, how do we organize the data and the processing? So before the object-oriented paradigm was introduced, that structured paradigm was the dominant. And in that paradigm, we would have the processing as its own unit. Okay, and then the data would be introduced to the processing as an input, and then after the processing applies them, it would come out as an output. All right? So depending on the language you're working with, the processing would be defined within a function or within a procedure. Now in Python, we are talking about functions. Also, the data, it's not just, it could be just a simple variable, or it could be a sophisticated data structure. Okay? And in Python, what we represent the data in objects, and the processing is represented in functions. So we've seen that paradigm is still present in Python. Even though historically speaking, when the object paradigm was introduced to replace that, and for some good portion of time, like languages like Java and C++, and then later on C# are fully object-oriented, and the promise was that object-oriented will replace the structured, okay? But what happened is that there are some pros and cons for each paradigm. So now languages like Python and JavaScript, for example, try to have the best of both worlds. So it is not completely object-oriented, but it has object-oriented features implemented. But at the same time, you can have some structured way of organizing things. And that's what we've been working with, right? So far, we've been defining functions. It's very different than how it would work in Java, for example. In Java, in order to print hello world, what would you need to do? So in order to print a hello world in Java, what would you need to do? You need to create a class, right? And then inside that class, you need to create a main method. And then inside the main method, you put the print statement, right? Now in Python, you don't need to do all that. You just call the function right away. Okay? And when you define a function, you don't have to define a function as part of a class, which is the case in Java and similar languages. In Python, you can just define a function on its own and just send it data and get the return from it, right? And that's what we've been working with so far. Now, the object-oriented paradigm principles, because they are very beneficial, even the languages like Python and JavaScript that weren't originally object-oriented, they started to introduce the object-oriented features in order to get the benefit from it, okay? So what are the object-oriented principles? You most likely are familiar with all of them from learning Java, if you remember them. So there's a concept, obviously we're saying object-oriented. So everything revolves around the concept of an object. And then there is the concept of a class and instantiation. We go through all these principles one by one. Okay, but the concept of an object, generally speaking, it determines how the data is organized with the processing that apply on them, which we put the data and the processing that is relevant to them in one bundle, and this bundle we call the object. So that's the main concept there. And then the data that is within that concept are called attributes or properties, and the functions that, like, if you normally define it as a function outside, like before if it's not inside an object, when we put it inside an object, you call it method. Okay, so the object is just the bundle or the encapsulation of some attributes and the processing or the methods that apply on these attributes. Okay, for example, let's say we have a payroll system. So we have employee, an object. So this is one of the objects that we care about. We care about data, working with employee data in order to calculate salaries and stuff like that. So the attributes of the employee object would be something like name. So there is the attribute name or the property name versus its value. And then there is another attribute name and it has value and so on. And then there are some processing, some functions that could be just reading or writing to these attributes, or could be performing some calculations on these attributes, right? But if you have a payroll system, you're not working with one employee object. You would probably working with multiple employees objects. And before the object-oriented feature that's called class was introduced, the way they dealt with it is that to duplicate the code that represents every object. Okay, so we would have to create one object for each employee, and you can see there are a lot of duplication, which is a very bad thing to happen when you duplicate the code. Okay, so in order to avoid duplication, the concept of a class was introduced. So a class is just the template of the type of similar that represents, the template represents the type of similar objects. Okay, so the object itself is a central concept, and then the class is just a template for similar objects. Okay, and in order to create an object out of that template, out of that class, we do what we call the instantiation, which is to create the instance, right? So the object itself, another term for it is the instance, and instantiation is just a process of creating an object out of a class. Okay, now do you remember how in Java did you do the instantiation? How did you create an object in Java? Remember? How did you create an object? Yes. With a new keyword, yeah. So that's one way. New keyword and new, and what comes after the new? The class name as a function, so that's what we call the constructor function. The constructor function. Okay. It is similar in Python, but with a slight difference. Now, it's important for you to understand that Python is not a fully object-oriented language like it is like Java and similar languages. So the features are desirable, so they implemented them, but they didn't enforce them. Okay, so there are some flexibility that is not allowed in fully object-oriented features. So they left it for some people like the flexibility, but it can be dangerous. So I'm just gonna try to point out some issues that you need to pay attention to in order to avoid confusion. Okay, so let's see, how would we define a class in Python? We just use the keyword class, all right? And then the name of the class, and as usual, we put the colon to indicate that there's some definition coming, okay? So here, for example, we have just two attributes, name and email. Okay, And remember that Python is weakly typed, so we don't define a type for a variable like we do in Java, right? Okay, so just the name of the attribute and an initial value. So this is one way to define attributes. Okay, so let me I'm gonna open a new file altogether.